Hey, geometry, still Unit 1 in constructions. We're doing lesson 5 today, which is construction techniques, perpendicular lines, and angle bisectors. Everything still relates back to circles. Because the radius of a circle is fixed, I can use a circle to make sure that everything that I draw from it is an exact measurement. So we use circles in geometry for everything. Just a little FYI, right? All right, so if we look at lesson 5, looking here, it says 2 circles. Points A and B are each at the centers of circles of radius A and B. I'm actually going to go over here and work. There we go. So that I can draw on it, which I have to move my head. Floating head. There we go. All right, points A and B are each at the center of circles of radius AB. So circle A has radius AB. Circle B has radius BA. Compare the distance EA to the distance EB. Be prepared to explain your reasoning. So we're comparing the distance from here to here. That is also radius of circle A, okay? AE is the radius of circle A, and then BE is also the radius of circle B. And since circle A and circle B have the same radius, any line I draw from the center to the edge has the exact same measurement. Ooh, there's another one. BF is the same as AF, all right? So really important there, compare the distance. They're the same. Compare the distance FA to FB. And same is very, it's not the best word to use. Congruent or equal measures. Okay, that means those words have a lot more weight in geometry than same, okay? And then draw a line EF and write a conjecture about its relationship to AB. So EF. Let's see, I should probably erase all this stuff. It says draw a line EF and write a conjecture about its relationship to AB. Well, I'll tell you what the conjecture is. I think it's perpendicular, and it actually is. All right? Because this distance is equal to this distance, I've made an equilateral triangle, and E to let's call X, the segment EX bisects angle E and cuts base AB into 2 equal segments and perpendicular. So many things I told you there. So we know that EF is a perpendicular bisector of AB. And that just means segment EF. So what I wrote, I'll say out loud. Segment EF is a perpendicular bisector of segment AB. Okay, that's what we're learning today. All right, so here is line L with a point labeled C. Use a straight edge and compass moves to construct a line perpendicular to L that goes through C. So we're trying to construct this line. And what's really cool is in the warm-up we learned if I have 2 points equal distance from C, which that is not, that means I can draw a circle around one point and it's equal to a circle around another point. And the line through those intersections, that's an intersection, I just make the dot bigger if I mess up, is perpendicular. And it bisects between this point and that point. Okay, so I'm going to switch over to GeoGebra, which you have access to also. In GeoGebra now, here we go. So, like I said, we want a line to go through C that's perpendicular. So I really need 2 circles. Sorry, So I'm going to make a point. Well, let's do this. put a point to the left of C. I'm going to draw a circle around that point. And my circle just has to be bigger than C. Okay? Now, if I can find the intersection up here and down there of a circle the exact same measurement. Nope, I've already messed up. I knew I did. Okay, first let's do a circle at C. Intersection C in here. Okay, so let's do that. A circle at center H that goes past C. And now I want to compass the exact same radius, but I need that at G. Okay, so what we've seen here is first I drew a circle around point C so that I could use the intersection of that circle and the line. And then I drew a circle centered at H. Just drew any circle centered at H, and then I copied that circle and made it the other intersection. So that gives me, let me mark my intersections of the circles. And now I can draw a line. Okay, so I know that that line is perpendicular to line L. Let's do it again. It's always good to practice again. So let's draw, if I'm trying to draw a circle, if I'm trying to draw a line perpendicular to line L through C, first I need just any circle at C. And then I would like to mark the intersections of that circle with line L. So I'm trying to draw a line here. So I need two circles that intersect up here and down there to give me a place to draw my perpendicular line. So I'm going to do another circle at H that goes past C. And I'm going to mark it down here. My dots get two. So now I need to copy circle H over to G, but it has to be the exact same radius. That's what I mean by copy. So let's find the radius of H. I'm going to put it at G. And there I've got the intersections here. The intersections of those two circles will tell me where to put my line. Okay, perfect. So if I were you, I'd probably write down, sketch a little bit of those steps, just bullet point them so that I remembered how to construct this on my own, okay? All right, so now we want to bisect this angle. I'm not sure why these are really connected, except that what I did, let's go over here. What I did over here, yeah, I kind of drew an angle. Let's do this. That's awful. I'm not very good at drawing with my new little. So I'm going to draw an angle A. Oh, golly. Oh, my gosh. So that right there is my angle. So AEB. How did I get this? I told you this EF is a bisector. How can I bisect that? What I really did was I drew, well, if I draw a circle around E, I know that where these intersect, if I find the middle of those two intersections, I can bisect that angle. So really, if I draw a circle at B in the exact same circle at A, I've got an angle bisector. Let's do it on GeoGebra. Hi. So I'm going to draw a circle at B. I don't want that D there. It's fine. Okay, so if I show the intersection of this circle, nope. If I show the intersection of this circle here and there, I know if I draw a circle at E and the exact same circle at F, where they intersect is going to be equidistant away. So let's draw any circle at E, except I want the dot to be over here. And then copy that circle and put it at F. That means that, remember, points, let's do the ray. So any point on ray BH is equidistant from E and F, okay? I just did an angle bisector, and I did that by, like, first I drew a circle around B, just because I needed to show intersection of that circle and my angle. And then I drew a circle at E, any radius, just has to be past the middle, and I copied that over to F. And that gave me an intersection point that is an angle bisector because, let's see, I'm going to do this. Well, if I drew a segment between E and F, what can you tell me about segment EF and its relationship to ray BH? It's a bisector. It cut it into two equal pieces, and it's perpendicular because that's how we drew it. All right, let's practice and draw it one more time. Oh. There we go. So if I want to draw an angle bisector, first I'm going to draw a circle at B. It can be a big circle, it can be a small circle. And then I want to show those intersection points. Circle and this segment, circle and that segment. Now if I draw a circle centered at E, it has to be past center. It can't be itty bitty, it has to be past center somehow. I want the dot to be over here though. And now I copy that circle, that radius, I'm going to copy it over here. Where those two circles intersect is my angle bisector, ray. Okay, I know it's an angle bisector because it also cuts segment EF into equal pieces and it's perpendicular to EF. All right, so again, you can write down just a few bullet points on how to do that construction, and it works the same on paper. And again, I'm looking over there, I know, and like, Miss Carly, why are you looking over to the right? It's fine. All right, so that was it. We have our summary. I've copied this summary into that shared Google Doc. It shows you how to do the angle bisector. It shows you how to do the perpendicular line. And when two circles intersect, it's really neat how they help us construct things. I've also added to your glossary the angle bisector. I think it's the only new thing from the glossary. But let's do, we'll finish up lesson 5. All right, good job. I hope you're practicing on your own.